So hey there everyone, this is Gaurav, and in this video we'll be solving a question from Leetcode. So the question states, the question name is squares of a sorted array. So we'll be given array nums which is sorted in non-decreasing order. That is, there will be always be increasing, and it could have negative values as well. So and we have to return the array of squares of each number. So we can see 4 has a square of 16, 1 has a square of 1, and they all are sorted. So when you square this number, it will, according to the sort, it will come before 10. So this is how the result would look like. So we'll be sharing two approaches that I got. And first one was, when I saw this, we want these elements in a sorted way. So I was thinking, if I use a sort method, it would take n log n complexity. So why not use some data structure that sorts internally? So for this, I use priority queue. So I'll be sharing what does priority queue means. So priority queue is a special type of queue in which each element is associated with a priority value and elements. So in simple terms, whenever you insert an element in a priority queue, it gets internally sorted according to its priority. So for this is an example of max heap priority queue. So by max heap priority queue, you can simply get to know the maximum value would be at the top. And if you insert some bigger value than 9, then it will automatically get sorted and the maximum value would be at the top. And if you insert any lesser value, it will automatically get placed where it should be. So if you place let's say 8 or 9, it will according to the priority, it will get itself placed. Okay, so I thought, why not to square every value and just push it into priority queue. And in our case, we don't want a max priority queue, because in our question we'll be needing the value minimum value at the top and the maximum value at the very end. So I'll be using min heap priority queue. So how to create a min heap priority queue, you can just look into this, how to do that. So this is a min heap priority queue, and for all the nums value, I've pushed each element square into the priority queue. So internally they have been sorted, and as we'll be returning a vector of int, so while we will start emptying all the priority queue, we'll be pushing all the top, from the top we'll be pushing all those elements to vector v, and from top to bottom, in the very end we will get the most element, and it will be in the last of our vector. So that is what we want. So this is how we iterate to priority queue, and after getting the top value, we'll push it into our vector v, and similarly we'll push we'll pop that value so that we can get to the next element. So by this we can get all the values, and in the very end we'll get the vector v, which will be our answer. So this was my initial approach, and it was a good way of using a priority queue. But I also saw that people are using it with 2 pointers, so I also looked into that and got to know about the 2 pointers approach as well. So how does 2 pointer approach would help in this case? So I have an example. So this was our initial vector. Okay, so we'll keep a record of an array, that is the result array, and what we want the maximum value to be at the very last, and the minimum value would be in the very first. So in this, if we square 4 minus 4, it will no longer be a negative 4, and it will place around in the right section of the array, right? So we have to keep looking into the elements at the very first and very last, because very first would be the most negative value, and they have a chance to get converted into a maximum positive value when we square it, right? So we have to take care of two elements, first and the last, and we will see which is more capable of making the greatest positive value, and whichever the value is left or right, we'll push that into our result array in the very end, and then we'll iterate to the previous index of that array, and we will just move left and right pointers to their respective position. So currently we will start with the loop in which we have the left pointer pointing to the first element and the right pointer pointing to the very last element, and we have an empty array of result. So as we know, we have five numbers, so I have created a result vector of 5 elements which are currently empty, or you can say initialize with 0, or just like memory is being allocated, nothing is inserted. So the first value would be -4. So we'll see if -4 square, that is 16, is greater than 10 square or not. So 10 square is 100. So we know right one is the maximum value. Okay, so we will push this 10 square into the very end, and we know that this has been completed. We will remove the right pointer to the previous one. So we have got the value that -16 is not the greatest value than 10 square. So we have pushed 10 square into the array, and we have removed the index. So now there are two cases, like -4 could be the greatest value, or 3 can be the greatest value. So -4 is 16 and 3 is 9. So we know 16 is the greatest one among both of them. So we'll push 16, and we will increase the left pointer to 1 before. So this would be the resultant pointer values, right? And in this we know -1 and -3, 3 has the greater value when we square it up, so it would be 9, and we will remove this pointer and create it here. Okay, so similarly now currently left and right, we know 1 square is 1 and 0 square is 0, so 1 would be the greater value, and we will increase it to 1. And now left and right both are at same place, and this is the last value index, and it is 0, so we'll square it up and put that in the element. So this was our approach for 2 pointer value. So I'll share that code also. So for easiness, I've created a size variable. So we have the number of values, like how many numbers are there. So we have the size. We have created a resultant vector which is being initialized with the size of n, or we can say size of size, right? And we have initialized left pointer to 0, very left, right pointer to the very right, that is size -1, and current is also so we have a current pointer also, so which will point that this is the value, and we will increase like to iterate in resultant vector, because we are filling those things from the right hand side. So we will having a current pointer which will point to this, and similarly when we start filling this value, it will go to the left hand side. So we know we have a current pointer which will be pointing to the very last, and then it will go towards the left side. So current will always decrease. Okay, so current will always decrease, left pointer will always increase, because we'll be going to the right hand side, and right, if we have this value, we'll be always decreasing the right pointer, right? So this is the so now we know why we are having the current pointer. So we will check while we will loop through the values until we have the left values lesser than right value, like these are not crossing each other, right? So we'll see if our left value square is greater than the right value square. If we know the left hand side is greater than the right hand side, then in the current index in the resultant vector we will store the greater value, that is left hand side one, right? And we will decrease the current index to -1, right? Because we will be decreasing all the current index, and as we got the greatest value from the left hand side, we will increase the left pointer one ahead, right? Because we will be increasing the pointer from the left. And similarly, in the inverse case, what we'll do, if the right hand side part is greater than the left hand side, we will have the resultant vector of current index would be number of right hand index square, and we will decrease the current pointer, which will be same in both the cases, and in this we will decrease the right pointer. So we will decrease the right pointer until left is reached, and after all those values are done, we will be having the resultant vector all full. So this is the resultant vector that we will be getting. So these are the two approaches that I came across and I've shared. So that's it from my side. Thank you.